Regulate. Regulators! Mount up.
Well, good morning, good afternoon, or good evening, depending on what time of day it is that you're watching this video. In this lesson, I'm going to go over with you polar coordinates, okay, which is another way of writing points, but we're going to write it in polar form, okay. Before we do that, let's take a look at this saying right here. Teachers open the door, but you must enter by yourself. Guys, that is so true. I can show you the stuff. I can work with you on the stuff. So can your other teachers. But you're not going to truly learn it. You're not going to really master it until you start doing it on your own. Okay, so remember that. Teachers open the door, but you must enter by yourself. All right, now let's take a look at polar coordinates. Okay, so you guys, normally everything we've done rectangular coordinates. We've been given a point with an X and a Y. And they pretty much give us directions from the origin of a graph. Here's the X-axis, here's the Y-axis. The X tells us how far left or right to go, the Y tells us up or down to get to our point. Okay, now when we're in polar coordinates, we're going to have a R and a theta. R is the directed distance, or the radius. If we're thinking now polar coordinates, we're just going to be going around in circles. So R would be the radius of the circle, or the distance it is from the origin. And then theta is the directed angle, with 0 being the positive, what we would call the x-axis, but now it's just going to be 0, it's just going to be right here. There is going to be no more x or y-axis, okay? Then they call the origin the pole. So let's look at a piece of graph paper. Here's a piece of polar graph paper. Okay, if we go around this, right, this is 0. Could be 0 degrees, or let's say radians, that'd be 0 radians. Then up here would be pi over 2 radians. This would be pi radians. Down here would be 3 pi over 2 radians. And then we get back to 2 pi radians. All right, and then in between, this I believe is going by 15, if we think degrees, 15 degrees, 30, 45, 60, 75, 90. If it's in radians, I believe 15 degrees is pi over 12. And then this would be 2 pi over 12, which would be pi over 6. Then 3 pi over 12, which would be pi over 4. Then 4 pi over 12, which would be pi over 3. And then 5 pi over 12. Then 6 pi over 12, and so forth. Okay. Now, when we're given a point, let's say I just throw in a point right here. Okay, we no longer have x's and y's. What we have is the radius. And look at this. This goes out 1, 2, 3 units, and it went in the direction of pi over 3 radians. So that would be the point 3 pi over 3. All right, let's say I had something, let's say way out here. Then this point right here is out 1, 2, 3, 4, 5. So it has an R of 5. And then its angle is going to be the, let's see, pi over 4, 3 pi over 4, 5 pi over 4. All right, if we're thinking in terms of degrees, that would be 225 degrees. Okay, now, you guys, one of the drawbacks to polar coordinates is there are more than one way to write these coordinates. Okay, the R could be negative, or the angle could be negative. Right? Let's say, for example, we came down here, and let's go with let's see, this is 270, 285. This would be 300 degrees, which would be what, 5 pi over 6 in radians. Okay, if I drew a point here, let's say we came out here 1, 2, 3, let's go 4. This would be the point 4, and then 5 pi over 6. Okay, instead of going clockwise, I could tell somebody to go clockwise, right? And then this would be the point 4, and it would be negative pi over 6. You guys, that's not 5 pi over 6. Darn it. My mental math let me down here. If I put 300 over 180, 60 goes into 300 5 times. It goes in 180 3 times. So that's 5 pi over 3. So this could be negative pi over 3. Right? Instead of going counterclockwise, we could tell somebody to go clockwise. Now, by the same token, let's say I'm on this same ray here. 1, 2, 3, 4. Right? This angle right here, if I keep doing this, this was 6 pi over 12, 7 pi over 12. This would be 8 pi over 12, which would turn out to be 2 pi over 3. Okay, this point right here could be 4 and 2 pi over 3. But if I change that 4 to a negative, it means go 2 pi over 3 radians, but then instead of going in that direction 4, go in the opposite direction 4. So this point right here I could also say is negative 4 and 2 pi over 3. Right? So there's an infinite amount of ways to write a point in polar coordinates. That's one of the drawbacks. But this is a nice different way to write points because we don't have an x and a y. Remember, we have a r and a theta. We have the distance from the pole, which is the origin, how far out we go. So this one was 1, 2, 3, 4. And then we have an angle, the direction we go. Okay. All right. Now, because anytime we have a point in polar coordinates, we should be able to write it in rectangular coordinates. So here's a few points we're going to do right here. This first one, we've got 4 pi. Well, guys, if we think about this, let's say we sketch this. We don't really need a piece of polar paper. We just need this. This is telling me go pi radians and then go that direction 4. There's the point 4 pi. Okay, if I'm thinking in terms of x and y, I went 4 to the left and I went 0 up. So that's the point negative 4, 0. Okay. So that was pretty straightforward one. This next one might be a little different though. Let's say 7 and then pi over 6. All right, well, what I'm going to do first is sketch it in the polar plane. So I'm going to go pi over 6 radians, which would be about there. And I'm going to go out this direction 7. So it's estimated to be about right there. There's my point 7 and pi over 6. Now, if I drew a line out here, that's my r is 7 and my angle is pi over 6. Okay, I could drop a perpendicular line down here to the x-axis and make a triangle, and then I could find the x and the y that get me to that point if we're thinking an xy plane. Okay, and looking at this, x is adjacent, 7's hypotenuse, so the cosine of pi over 6 is going to equal x over 7. I can use the same technique to get y, but I use the sine of pi over 6. Whoops, would equal y over 7. So it basically turns out that x is 7 times the cosine of pi over 6, and y is 7 times the sine of pi over 6. Or basically, you know, we're doing here, x basically just figured out that x is r times the cosine of the angle, and y is r times the sine of the angle. Okay. So let's see here. Pi over 6, cosine of pi over 6, that'd be 30. Cosine of 30 is square root of 3 over 2, so this would be 7 square root of 3 over 2. And then the sine of 30 is a half, so this would be 7 halves. So in rectangular coordinates, this point would have an x of 7 square root of 3 over 2 and a y of 7 over 2. Now I guess I sort of want to go back to this original one here. If we're saying x is r times the cosine of the angle, then in this situation right here, x was 4 times the cosine of pi. And y is r times the sine of the angle. You guys, look at that. Cosine of pi is -1 times 4 is -4. Sine of pi is 0 times 4 is 0. So we get the -4, 0. That's a nice thing to know right there. All right. So this one right here, 4 and 7 pi over 4. Okay, if I want to put that in rectangular coordinates, I'm going to use my little shortcut. I'm going to say that x is 4 times the cosine of 7 pi over 4. And y is 4 times the sine of 7 pi over 4. Okay, so notice how everything we've done in trigonometry, x went with cosine, y went with sine. Always. Okay. So let's see. Cosine of 7 pi over 4 is square root of 2 over 2. That's in the fourth quadrant, so it's positive square root of 2 over 2. So this would be 2 square root of 2. And then sine of 7 pi over 4 is also square root of 2 over 2, but in the fourth quadrant it's negative. So this would be -2 square root of 2. So the rectangular coordinates that are the same as these polar coordinates are 2 square root of 2 and -2 square root of 2. And you guys, this makes sense if I was to plot this point. I'll go back to our polar graph here. All right, here is, I'm going to move these extra things that I wrote here. Okay, 7 pi over 4 would take me around to here, and here's the point 4. So we just figured out this is the point 4, or the radius of 4. 1, 2, 3, 4. This is the point 4 and 7 pi over 4, which in rectangular coordinates is +2 square root of 2 and -2 square root of 2. Right? Because we go 2 square root of 2 to the right, 2 square root of 2 down. But notice in polar, we don't go left or right, up or down. We go a direction and then a distance. All right, let's try one that's got negatives on it. Okay, so we've got -1, -3 pi over 4. Okay, so guys, I'm going to picture this first on a graph. Let's say here's a polar coordinate graph. Okay, what we want to do is the angle first. So we're going to go -3 pi over 4, which means we go, this would be -pi over 2, it'd be over about here somewhere. Okay, if this was the point 1, -3 pi over 4, that would be the point right there. The -1 just means instead of going that direction, right, that angle, going distance of 1, you do the opposite of 1, so you go back this way. So here's the point -1, -3 pi over 4, which I feel like would be the same as 1 and +pi over 4. Okay, but you guys, the nice thing about this is to find the x and the y, find the x, we could just do the r times the cosine of the angle. And to find the y, we take the r times the sine of the angle. And I know that sine and cosine, whenever it's over 4, that references to 45, they're always square root of 2 over 2. And in this case, we're in the third quadrant where only tangent's positive, so they're both negative. So we turn out getting for our x positive square root of 2 over 2, and our y, and our y is also positive square root of 2 over 2. Okay. And you guys, you think this should be negative, but remember this got flipped over here, so it's positive. So there's our point. Okay. This would be the same as doing 1 times the cosine of pi over 4 and 1 times the sine of pi over 4. Okay. All right, so if we can go from polar form to coordinate, or rectangular coordinates, then we should be able to go from rectangular coordinates to polar coordinates. So here's 4 examples we're going to do. And let's see. Yeah, we'll save that the easiest one for last. All right. So we've got negative 4, 4. So my advice would be whenever you got to do this, sketch this first. All right, so the point negative 4, 4 is 4 to the left and 4 up. It's right there. So we want to find two things. We want to find this R and we want to find this angle. Okay, those are the two things we're looking for. We can always drop a perpendicular line down the x-axis and make a right triangle right here. Right? We went 4 to the left and we went 4 up. Right? The negative just means we went to the left. I could use the Pythagorean theorem to find R here. Right? R squared should equal 4 squared plus negative 4 squared. So R is going to be the square root of 16 plus 16, which that would be the square root of 32, which would be 16 times 2. Square root of 16 is 4. So the R is 4 square root of 2. And you guys notice how there to find the R, we basically just took the square root of x squared plus y squared. And that's another nice thing to file away. Now, we can't find theta, but we could find this angle right inside there. The angle inside there would be tangent, right? The tangent of A would be 4 over negative 4. So tangent of A would be negative 1. And tangent is 1 at 45. Right, we want it to be negative 1. Or actually, you know what I'm going to do here, you guys? Here's where the negatives throw me off. Right? That negative just gave us the direction. Right? I'm not going to put this negative in here because the negative just tells us the direction. It tells us to go left instead of right. So I'm just going to take the absolute value of that, and 4 over 4 is 1. Tangent equals 1 at 45 degrees, or pi over 4. So that's our angle inside here. So when we write this in polar form, the R is 4 square root of 2. And then the angle is going to be pi over 4 short of pi, which would be 3 pi over 4. Or 135 degrees if you prefer to work in degrees. Okay, you guys, here's another thing right here. To find angle A, right, we just took the tangent of A and we let it be y over x. Remember, tangent is y over x. And a nice thing we learned here is don't put the negative in there, right? Just go with the absolute value of those things. Okay, so let's try this next one. And you guys, here's the thing too. I'm going to grab my calculator here because we could also confirm this with our calculator. Okay, watch this. If I take my calculator, I'm going to go in the regular mode here. I'm going to check my setup. I'm in degrees. Since I did this in radians, I'm going to change my angle to radians. Okay, watch this. We said that x was the r, which in this case is 4 square root of 2, times the cosine of the angle. So times the cosine of 3 pi over 4. Look at that, negative 4. We said y was the r, which in this case is 4 square root of 2, times the sine of the angle, which is 3 pi over 4. Look at that. Is we can always check these. We can confirm if this polar coordinate matches the rectangular. All right, so let's do this one. This is a nice one because we're in the first quadrant. So when I go to sketch it, all right, I'm just going to be here in the first quadrant. This point is right here. Right? So we want to figure out, okay, if I come up here, what's this R? And also, what's this angle right here? Well, we went 2 square root of 3 to the right to make a triangle here, and we went 2 up. So r squared should equal 2 squared root of 3 squared plus 2 squared. Or r is going to be the square root of x squared plus y squared. So when I square 2 square root of 3, I square 2 and I get 4. If I square square root of 3, I get 3 times 4 would be 12. And then 2 squared is 4. So r is the square root of 16, which is 4. Right? And then here our angle right there, the tangent of my angle is going to be y over x. So tangent has to be 1 over square root of 3. Well, tangent is 1 over square root of 3 at 30 degrees. All right, or if I want to think in radians, pi over 6. Right, we can write these in degrees or radians. I started writing them in radians, so I'm just going to keep writing them in degrees, or writing them in radians. So r is 4, and my angle is pi over 6. Okay. All right, this next one, because we could pretty much now find the r pretty easily, right? R is always just going to be the square root of x squared, so 3/2 squared. The negative just tells me to go to the left, plus the y squared, 3 squared of 3 over 2 squared. So in this case, I'm going to get the square root of 9/4. So that's what I get if I square 3/2. Then here I'll get 9 times 3 will be 27 over 4. So I get the square root of 36 over 4, which is 9. So r turns out to be 3. All right, now to find the angle, okay, this point is to the left and down, right? So when I make my triangle here, I'm actually going to find this angle right here. So I'm going to have to do 180 or pi plus that angle, okay? So the tangent of the angle I know is going to be y, which is 3 square root of 3 over 2 over x, which is 3/2. So the tangent of my angle, if I flip this, I'm going to multiply this by 2/3. Right? The 2's cancel, the 3's cancel. This is going to be square root of 30. So A is going to be 60 degrees. Or in radians, pi over 3. Right, I'm going to go ahead and write this answer in degrees just to show you it doesn't always have to be radians. So this one, the r is 3, and then the angle is 240 degrees. Because we want 180 plus that 60. So there's my point in polar coordinates. Okay. Now, this last one here, this one's easy just to picture. Right? The point 0, 1 is right here. So from the origin, we went down 1, so the r is 1, and then the angle is 90, 180, 270. Or in radians, I'll go back to radians, 3 pi over 2. You guys, it really is that easy. Okay? Don't make it harder than it has to be. Okay. Now let's see here. Here's some things we just figured out working this out. R squared was x squared plus y squared. X was r times cosine of theta. Y was r times sine of theta. And the tangent of our angle is y over x. But this is a little misleading because we have to make sure which quadrant we're in. Okay, if we're in the first quadrant, then whatever we get for theta, that's our angle. If we're in the second quadrant, we do 180 minus the angle. The third quadrant, we do the angle minus 180. In the fourth quadrant, we do 360 minus the angle. Okay. Or if you're in radians, replace the 180 with pi and the 360 with 2 pi. Okay. All right, guys, now that we've done that, we should be able to convert equations from polar form to rectangular form and vice versa. So let's convert 4x plus 7y minus 2 equals 0 to polar form. Okay, and these are the 4 things we're going to use to convert from rectangular form to polar form and vice versa. So maybe I'll copy this for us right here real quick, and I'll put it in here. All right. So whenever we want to go to polar form from rectangular form, whenever we see an x, we should think r to cosine of theta. So this is going to be 4r cosine of theta. Plus 7, instead of y, I'm going to put r sine of theta. R sine of theta. And I'm going to take this negative 2 to the other side. It becomes positive 2. Okay. Now I'm going to factor out an r. I'll get r times 4 cosine of theta plus 7 sine of theta. That's going to equal 2. And then I want to solve this for r. So r is going to be 2 divided by 4 cosine of theta plus 7 sine of theta. And look at that. We converted it to polar form. Now, guys, the reason why we wanted to solve that for r is this right here. If I go to the menu and I go to the graph, okay, I'm going to delete these things out. Okay, if I go to type, watch this. It's got r equals. I could graph this. I could graph 2 divided by 4 cosine of theta. Oh, look at that. It puts theta in there when I'm in this. That's pretty cool. Plus 7 sine of theta. And I think right below that, I'm going to go back here, go back to type. I'm going to go y equals. If I was to solve this for y, I'd have 2 minus 4x divided by 7. Okay, I'm going to turn that off for a second. I'm just going to graph the 2 divided by 4 cosine of theta plus 7 sine of theta. So I'm going to graph that. Okay, now I'm not seeing anything, but I'm going to go to zoom. No, I'm not going to go to zoom. I'm going to go to the standard window. See what happens here. Ah, look at that, you guys. It looks like a line. Okay, when we hit standard window, it still goes negative 10 to 10 for x, negative 10 to 10 for y, but then it adds r, right? It goes from 0 to 2 pi. Okay, now I'm going to go back into the equation here. I'm going to turn on that line. I'm going to graph both of these things. Ah, look at that. The line is the same. Now, the reason why, if you're thinking, hey, when we graph just the polar, it didn't keep going, it's because it really does, but the calculator just can't show it. Okay, we could play around with the window some more to get to show it, but it's the same thing. All right, let's try this one right here. Let's convert this to polar form. All right, so x squared minus y squared equals 9. Well, whenever I see x, I'm thinking r cosine of theta. So there's x squared minus y is r sine of theta. So there's y squared. That's going to equal 9. So if I square this, I get r squared cosine squared of theta minus r squared sine squared of theta. That equals 9. I can factor out a r squared, and then I'll be left with cosine squared of theta minus sine squared of theta. And then, hey, that's an identity right there. That is cosine of twice theta equals 9. Then I'll divide by that, and r squared will equal 9 over cosine of 2 theta. Okay, then I'd probably just leave my answer like that. I could take the square root of both sides and say r is plus or minus 3 over the square root of cosine of twice theta. Okay. But the main thing was here just to get it in terms of r in terms of theta. And there we did. All right. Now, you guys notice too how this is a little different. When we have x and y, we always try to get it y in terms of x. Now when we've got r and theta, we're trying to write r equals, right? So we're switching which one's the independent variable, right? In x and y, x is independent, y depends on x. Here, r depends on theta, okay? Now, guys, if we can go from polar to rectangular, or rectangular to polar, then we should be able to go from polar to rectangular. Okay, so I've got r equals 1 over 1 minus cosine of theta. I want to get this into rectangular form, x's and y's. So I'm going to cross multiply. I'm going to do r times 1 minus cosine. And I'll get r minus r cosine of theta equals 1. Okay. Now, r cosine is just x. And then r, well, I know r squared is x squared plus y squared, so r should be the square root of x squared plus y squared. Ah, look at that. And if I bring the x over here, I'll get the square root of x squared plus y squared equals x plus 1. And watch this. If I square both sides, then I'll get x squared plus y squared equals x squared plus 2x plus 1. And you guys, look at this. I could subtract the x squared from both sides, and it turns out that y squared would equal 2x plus 1. So guys, this is just a sideways parabola. All right, I'm curious about that. I'm going to watch this. If we wanted to graph this, all right, I'm going to clear these things out. Okay, I'm going to go back to type all y equals. If I wanted to graph this function, I'd have to have two graphs. I'd have to do the square root of 2x plus 1. And I'd have to do negative square root of 2x plus 1. Look at sideways parabola. Okay, now watch this. If I delete these out, I change my type and I go to r equals, and I graph 1 divided by 1 minus cosine of theta. Look at that. Because that's one of the advantages of polar coordinates. We can graph relations with one equation. Where in rectangular form, if it's not a function, we need two equations, okay, if it's a relation. Pretty cool. All right, let's try this one right here. Let's see. And if we can get this one, I'll feel pretty good that we got this down. So r equals r cotangent of theta. Now, you guys, some people might think right away divide both sides by r, but that's not good. That's going to get rid of the r, but there's no way to make cotangent into x and y, right? We need r's in there to get x and y. Now, we could replace the r with square root of x squared plus y squared, but I don't think that's going to get us anywhere. Well, it would. Then we'd have to square both sides. Something in the back of my mind is telling me to change cotangent to cosine over sine. Okay, now if you're sitting there thinking, saying to yourself, hey, that's exactly what you want to do, because now you can multiply both sides by sine, and on the left you'll get r sine of theta, and on the right you'll get r cosine of theta. And you guys, look at that. R times sine of theta is y, r times cosine of theta is x. So in rectangular coordinates, that's just y equals x. That's awesome. Okay, guys, these polar coordinates are different than what we've been doing. When you take calculus, especially in calculus 2, you're going to do a lot of stuff with polar coordinates. They're very, very helpful. Think about it. We live on a curved shaped planet, right? Polar coordinates go around curves. That's why we really want to focus on these. So do the homework, ask questions, study, and most of all, always endeavor to persevere.